This is my AP Calculus 12 final project. First question I'll be solving is hx equals parentheses 2x cubed minus 4x parentheses cosine x all over sine x plus x squared. First, we can notice that the top function is being divided by, the bottom function. But in the numerator, we also have product rule. And we know that because there's a function being times by another function. So let's address that real quick. We'll have u be our 2x cubed minus 4x, and v be cosine. So when we take the derivative of u, we get 6x squared minus 4. Take the derivative of cosine, we get negative sine x. Apply the product rule. This is what we should do, or should get. Quotient rule. As a reminder, this is what it looks like. G of x times f prime x minus f of x times g prime x all over gx squared. So it's just simple plugging into the formula of what we have. And this is what we should get. But we can also notice that 6x squared minus 4 and 2x cubed minus 4x all have something in common. Like they all can't be have like a common factor within their group. Just to highlight them in case some people aren't able to find them. 6x squared minus 4 have a common factor of 2. 2x cubed minus 4x have a common factor of 2x. So to put in simple terms, this is what it should look like. Because it has a common factor of 2, we have 3x squared minus 2. Because it has a common, and 2x cubed minus 4x have a common factor of 2x, we have x squared minus 2. And to put that into our equation, to go a little further, take an extra step, this is what it should look like. For my problem number 2, find dy dx using logarithmic differentiation. I'm given the problem y equals x to the power of sine x. And because I'm using log differentiations on taking the derivative, I'm going to take ln on both sides just so I can get that sine x out of the way. This is what it should look like, but of course, naturally, the sine x is going to come down. We're also going to implicit differentiate this equation. So the y will be out of there, and that's why we're going to find dy and dx is implicit. And we should get that y over 1 over y times the dy dx, because of that ln y, equals cosine, when we take the derivative of sine x, times the ln x plus sine x times the 1 over x. And then solving for dy dx, simple algebraic, just isolating for dy dx, we should get dy over dx equals x to the power sine x as the original function, and timesing cosine x times the ln x plus sine x times the 1 over x as our final solution.